A company spends decades building a reputation, but a single viral post can erase that value in milliseconds. Protecting that asset has shifted from a public relations function to a real-time data engineering challenge. In the past, organizations tracked newspaper clippings or focus groups manually. Today, continuous high-volume data streams pour in from platforms like X, TikTok, and LinkedIn, making manual tracking mathematically impossible. Transifin entirely subjective human variables, like trust and reputation, into quantitative metrics like sentiment scores requires a programmable pipeline. First, social listening acts as a raw data scraper, pulling in keywords. This unstructured text feeds directly into sentiment analysis, the computational logic processor. Modern reputation management relies on these intelligent data pipelines to actively identify and mitigate reputation risks as they happen. This architectural framework diagram outlines the 5 pillars of organizational reputation: identity, perceptions, communication, performance, and external influences. In a computational system, these act as continuous input nodes, funneling data toward a central hub. Millions of raw data packets, representing customer reviews, social media comments, and metadata, flow continuously from these external pillars into the main processing hub. Inside the hub, natural language processing handles the classification function. The sentiment analysis algorithm evaluates the emotional context of the text and categorizes each unstructured data packet into one of 3 distinct streams: positive, neutral, or negative. The system then passes these tagged streams through secondary layers, like trend analysis and competitor benchmarking. By plotting the frequency and volume of this sentiment over time against a baseline, organizations can identify macro shifts in public perception. By aggregating all these metrics, the system calculates a composite, real-time reputation score for the organization. This continuous, automated classification allows systems to achieve early detection. They flag systemic issues and emerging crises long before manual human intervention is possible. This looping flowchart represents the continuous 5-stage reputation lifecycle: build, maintain, monitor, protect, and recover. The computational complexity of this loop lies in the transition between the monitor and protect stages. Here, the system relies on machine learning for anomaly detection, establishing a baseline of normal sentiment variance. The algorithms train on historical data to learn what typical daily chatter looks like. Once that baseline is set, the system continuously scans incoming data for sudden, statistically significant deviations. Imagine the University Utara Malaysia student portal suddenly goes offline during exam week. Consider which life cycle stage this triggers and the technique used to catch it. The sudden spike in negative student feedback breaches the baseline threshold. The anomaly detection algorithm catches this deviation, flashes an alert, and instantly shifts the loop from the monitor stage into the protect stage. Effective crisis management relies on this predictive modeling. Catching an anomaly early provides the time needed to implement corrective actions before reputational damage escalates. Once a threat is detected, the system executes a 5-step automated management process: monitor reputation, analyze perceptions, identify risks, develop strategies, and evaluate outcomes. This node link graph visualizes social network analysis. This is the critical final layer of the pipeline. While sentiment analysis tells us what is being said, network analysis tells us who is saying it by mapping the influence of each user. Using graph theory, the system calculates node centrality to identify key opinion leaders. If an isolated user posts a negative comment, the risk remains low. But if a highly central, well-connected node outputs that same negative sentiment, the system tracks how that sentiment propagates to connected users and escalates it to a severe risk alert. By mathematically fusing natural language processing with social network analysis, computer scientists architect robust automated defenses. These systems ensure that an organization's most valuable intangible asset is monitored and protected at scale.